Without further ado, as is obligatory these days, you kind of introduce yourself. Now, I've got this little knitted puppet as my avatar on everything because about 5 years ago, my wife came running in saying, Jerry, 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 you're on telly. And this was a Dogs Trust ad, which has knitted figures. I may not have had a beard at that time, so it doesn't quite work now. So I'm old. It's a talk about legacy. Of course, I have to be old. I remember Java 1.0. I used it. I remember before then as well, but yeah. I've been around the block from a development point of view, where I've sort of made software for lots of different places. I've also dabbled in breaking software, where I turned around and did a bit of security, which mostly involved poking things with a stick until they break, which they do surprisingly easily. And very lately, I've decided to be a head of engineering, which means that you juggle lots of plates and don't feel like you achieve anything. So again, legacy feels appropriate. So this talk is about legacy. What I want to do is I actually want to sort of first talk about what it actually is, because that's not entirely clear all the time. I give a little preview on something that I call the maintenance death spiral. Remember that. That's my drama piece done for today. I'll be talking about metaphors, why experience matters. Sorry, I got distracted because the screen went off. I'm just buggering up the recording now, so yeah, good. And how you can sort of work with legacy, what you can do to fix it, and what legacy can give to you. So to start off with, so we'll talk about what legacy code is. I like to use Michael Feathers' definition. Michael Feathers said that the main thing that distinguishes legacy code from non-legacy code is tests, or rather a lack of tests. With tests, you make things better. Without them, you don't really do anything. I recommend the book. It is quite old because, legacy, obviously, we need to age things nicely. But yeah, so what does that mean? Am I good? Am I good? So, what it does mean is I'd like to sort of take a little step aside to a project that I did with, how should we call it, the UK's premier tax collection agency, HMRC. And what it was a project about taking a set of services out of a data center, lifting them up and dropping them in the cloud. Now, I was actually 7 years with this project. It didn't take 7 years to complete, but the interesting thing is when you tell somebody, what project are you involved in? Oh yeah, I'm lifting and shifting some legacy services. I don't think a lot of people kind of really go, yeah, that sounds exciting, let's do it. But actually, as I will hopefully show you through a few anecdotes, it was exciting and it did teach me a massive amount of things. Now, to sort of put things into perspective, this kind of thing is used to submit your tax return in the UK, which happens on the 31st of January. Which means because it's taxes, nobody does it in advance. The traffic looks a bit like that, a super sort of J-drop, because everyone does it at the last moment, because tax can be taxing. So, code without tests is legacy code, like Michael Feathers said. What does that really mean? Now, in the case of our lift and shift exercise, as is usual, when you do deal with some legacy code, we were given the zip files of the source code. That's what we got for migrating the services out of the thing. We didn't really get documentation. We didn't get lots of background information. The people who had written it, they had left 10 years beforehand. It's been through a few suppliers since. I might be embellishing certain things for dramatic effect. So yeah, essentially we couldn't trust the code. We couldn't trust anything, so because the tests were, well, some were existent, some were commented out. A lot of them were commented out, come to think of it. And so we had to sort of say, well, we can't really trust that code, so what can we do with it? I mean, as it happened, it was a lifting and shifting exercise, which meant that we were kind of actually trying to replicate the bugs. But then we sort of started running the services, and we didn't want the bugs anymore, so we started adding tests to it. Now, I'd like to qualify that a little bit to say that, you know, code without tests that you can trust is legacy code. It's not enough to have a folder called test in your source repository. If you don't know what the tests are doing, and if you don't know when you run them, that they'll actually pass, and if they pass, that it actually meant they test something, then you still have to think of your system really as legacy. And again, I'll take it one step further. It isn't enough that you can trust the tests. People that you work with or people that you hand the work off have to trust the tests as well. If you write some spaghetti tests that test something and nobody understands, it's no good really. You know, you end up back in the situation where, you know, you give somebody a zip file full of source code. In the instance of it, that zip file contains 7 million lines of code, so it was not the easiest thing to do. Now, I know this is DevOps days. I know it's late in the day. Some of you might have been observant enough that I used classic cars in the last 3 slides. Now, classic cars are actually quite expensive. They're valuable. What about classic services? Now, as it happens, classic services was the moniker that we gave ourselves when we did the lifting and shifting, because we didn't want to call ourselves legacy services, because it's just such a loaded term. So legacy systems, really, they're the ones that make the money at most big organizations, at most banks, at most insurances, at governments certainly. Somewhere at the center of it is a big old legacy system, some mainframe that nobody understands, but it's actually, when you think about it, these are the systems that have continuously provided value year after year after year. They're quite stable, and if you try to take them out, things stop working. There's actually a funny anecdote about that in the UK government. Somewhere in the Cardiff office was a mainframe, and there was some flooding, and the floor that the mainframe was on sort of gave way, and the mainframe was held up by the cables, the network cables that were plugged into it. But so important was the legacy system that the people insisted that the contractors that came in prop up the mainframe and build the floor underneath it without taking those cables out, because, well, this is the system that is crucial. So, interesting thing. Now, one of the things with legacy code as well is that complex code will be legacy code. And if you write it today, in a few months, or in case of the code that I write, in a few weeks, it will be legacy code. So, back to a little story about lifting and shifting. The interesting thing that we tried to do was to say, okay, well, the code itself is old, but there's no need for us to turn around and say, we need to approach this using, waterfall modeling or some old things. So we were actually quite agile about it. We ended up building something in front of it, a nice little knob that we could turn to sort of switch between the old and the new system. And that allowed us to be quite agile about lifting and shifting the code. Right, I was introducing this, hopefully nicely dramatic. I want to talk about the maintenance death spiral. This is what usually happens when people deal with legacy code. You can't recruit for it because nobody wants to touch the old stuff. It's old and there's gaffer tape that holds it up, and people just don't really want to go and support. What does that mean? So you can start anywhere in this little circle. If you've got poor system knowledge, then that means that people don't want to touch it. If people don't want to touch it, you can't improve it. Because you can't improve it, people don't really want to work at it, so they leave, which means that you have a lack of system knowledge. And round it goes. And that's sad, isn't it? And that's the way that systems just become abandoned, the maintenance death spiral. Nobody creates that sort of code intentionally. You know, somebody creates some code and it gets created, and then it gets abandoned. I like that particular XKCD comic. It can be used for anything. Mostly, I think in that context I was using it for security, but legacy anywhere. Right, so dealing with legacy. This was, as again, I know you're a very observant lot, this is pre-COVID times when we still had people around a whiteboard and sticky tapes, and we write things on it. But this is how we dealt with that said system. We wanted to make improvements. We had bugs, we had planned work, and we wanted to increase the operability of the system. We split them up into 3 different streams, and we made sure that we sort of measured the sort of how much we did of each. And if we spent too much time just fixing issues, then we kind of knew, well, we're not making things better. If we don't spend any time on planned work, it meant that we're not giving the client what they want. You know, it's no good making things better and fixing bugs. So this was one thing that very quickly allowed us to sort of figure out how to deal with it. Right. I'm going to take a little step back now, because as I've sort of alluded, legacy is quite a loaded term. You know, we talk about greenfield and brownfield development, where greenfield, the sunlit uplands of, you get the new shiny stuff, and you know, it just sounds like where everybody wants to be. And if we say dealing with maintenance is brownfield, the dirty coal mines that nobody wants to go into, it's not really appealing when you want to sort of say legacy isn't bad. Yeah, brownfield. Now, Andy Hunt and Dave Thomas used a metaphor for saying that software maintenance is a sort of garden. You kind of have to keep working to sort of stay still. You have to make improvements. I still think it's a bit of a weak analogy for legacy systems. If I quickly take a detour to construction again, usually construction systems, you kind of have the big national chains that builds the houses in, and then you've got Dave, the plumber, who also does a bit of roofing, who does the maintenance. In that analogy, I guess you have the big 4 consultancies coming in and dropping a nice shiny system in it, and then leaving it with some offshore outsourced people to figure it all out, who then leave and, yeah. Oh. I like this sort of metaphor better for legacy. It's cathedral renovation. You know, you have to really look at the plans. They're lost in the mists of time. The skills are no longer available. But the thing is, they actually did know what they did back then, because, you know, if you look at the Sistine Chapel, that's old. There's no steel or glass involved. It's rubbish, isn't it? That's my legacy analogy. It's not always just because something is old, it's crap. Now, I want to talk about why experience matters. Typically, what you find is that the new guy gets sent on to support. So it's like, right, you've drawn the short straw. We want to build the newfangled DevOpsy framework supported cloud-based thing, you can go off and play with the legacy thing. Just don't touch anything, make sure it still works. I think, again, that's not the right sort of approach, because when you think about it, if you deal with legacy code, you have to have quite a lot of skills to find out how something works together, usually without any documentation, like I said. The system, the HMRC system that I was involved with was 7 million lines of code. We couldn't analyze everything because one system had 400 screens, and even trying to create based on, kind of like what I said the other day about escaping legacy, to do all the mapping would have just taken forever. So we had to be very specific, very focused on where can we improve things, where can we make things a little bit better, where can we add a bit of automation. But you can very carefully make changes to improve it. Now, this is a DevOps conference, so obviously no DevOps conference will be without the 2 pizza team size. It's obligatory, I think it's in the contract. One thing that is quite sort of dear to me is that too many times when people talk about software teams, they talk about, oh, have we got enough resources to do this? Humans are not resources. They're people with feelings and skills and things. Calling them resources, I think, is quite insulting. This is not something that is just for legacy, obviously. But moreover, finding the right engineers is hard, and keeping or finding the wrong engineers is expensive. If you get somebody in that doesn't know what they're doing, you can't just go, oh, it didn't work out, off you go. So to just sort of say, oh, we've got a legacy system, let's send it out to tender, the cheapest contract wins the bid, it doesn't really work. I was involved with, when we finally handed off that HMRC system, because HMRC procurement rules mean that you have to know the right way of being on the right framework to contract. The next supplier that came in was on paper cheaper. They just had to put twice as many people on it, which made them more expensive. I'm not bitter at all. I also want to talk about, in terms of teams, that is really important. Again, we talk about sort of agile software development. You want your autonomy, you want your alignment. Even when you deal with legacy, you don't want to sort of say, yes, we tell you exactly what you do. If you don't get the people involved to be able to be masters of their own sort of destiny in order to change systems, then it's not going to work. So this is how we used to work. Again, working in an office seems strange now. The dartboard is how we organized our stand-ups. Whoever was furthest away from the center had to run the stand-up. The Batman symbol was the person who had to look at the logs. You sort of a Batman, you just crime fight. And as part of the team, you had to learn one of 3 skills. You either have to do a Rubik's Cube or juggling or lock-picking. That were the rules. It was a lot of fun. It was a lot of fun working with legacy. And it wasn't about the code, it was about the team that you're in and the sort of the philosophy that you had, how you practice it. Yes, this was then during COVID. My little Harry was born just before the COVID hit. So yeah, he's now what I call the substitution clause. Yeah. He was code reviewing. It's pair programming, isn't it? Yeah. What makes a great team for legacy and not legacy? Same thing. Now, we're getting towards the end of my whistle-stop tour. Usually when legacy code comes up, somebody will always say, well, why don't we just rewrite it? We get rid of all the old stuff, bring in something new, and it'll be so much better. Yeah, we do it properly. We have a nice tech stack. The new team will build it and do it right, and yeah, we'll do it using a big bang replacement. But hold on, the existing team is the one that has got all the domain knowledge. So how do we? Yeah, the people who look after the current system, we don't want them to build the new system. That's going to work, isn't it? Obviously, anytime somebody mentions Big Bang replacement, you have to bring up the story about, is it Mosaic and Netscape, when they decided that Mosaic wasn't working great, so let's just rebuild it. 2 years later, Microsoft had eaten their lunch and nobody knew what Netscape was anymore. The problem with Big Bang replacements is they hardly ever work. It's much better to sort of take small bits of a system and start replacing it, because you can then put them in production. I was involved in a Big Bang replacement of a system. We got 80% through it, and then the project was cancelled because we ran out of money. And if we had made small changes to the existing system, we could have kept that. So, a warning here. Right. Lastly, I'd like to talk about that legacy is actually a really great teacher. You know, invoking Kennedy, ask not what you can do for legacy, ask what legacy can do for you. Well, for me, it taught me a huge amount of things. Now this, again, keen observers that you are, this is just downstairs. You look out over the paved road. It is now my sincere belief that this is where Netflix will have come up with the paved road, because it's such a great picture. You have guardrails and everything, multiple ones, small ones, and if you go over both guardrails, you end in a drink. Anyway, I digress. What's working with that gnarly system, those 7 million lines of code that were 15-year-old Java, tied to a version of Hibernate and Spring Boot that couldn't be updated because they made customization that every time you looked at it, it broke. Okay, I'm exaggerating again. It gave me a different career. I was a developer. I started breaking things and finding little things where I would find that somewhere something was commented out, which meant that it wasn't encrypted, which meant that I sort of kept digging, and suddenly you had remote code access to a system. That was fun. It was a single line of code. You had to know where to look. I learned how to work with complex systems, how to add value without rewriting everything. And I also found out that not all solutions are technical. Sometimes a spreadsheet and a list is the right kind of thing. Absolutely. And I also sort of rediscovered the Agile Manifesto. That my favorite one is people over process, and when you sort of work in the right way with the right team, anything can be absolutely fun, and that made me discover an interest in, you know, meeting cool people that sit there at the front row and over there and over there. I'm not leaving anyone out. You're all cool. I mean, I'm not really sure why I'm saying this, because the beer later is free. Anyway, it has taught me a lot. So really, if there's one thing you take away from this, yeah, I kind of did the slides wrong there, I think. if there's one thing to take away from this, celebrate and measure your success. Yeah, it doesn't really work. Anyway, I'll skip over that. So, if there's one thing to take away from this talk, is that legacy code is not to be feared. It can be, I'm not saying that it always is, because I have seen some of the .NET code. It can be actually good fun to work with. Now, personally, my recommendation for any young engineer would be learn COBOL. All the engineers that know anything about COBOL are about 70. They're retiring, they're dying. Somebody still has to look after the mainframes, because if there's anything that we've learned, it is really hard to replace all those legacy systems. And usually what happens is that somebody comes along and says, yeah, we will do a massive replacement and everything will work, and then it crashes and burns and they kind of go, can't we just go back to the old system? Yeah. So I've been, Gerald, come and speak to me later or give me questions now. Yeah. Leave a legacy.